What are virtual particles in zero-point energy? Imagine the emptiest space you can think of, completely silent and still. Now picture that even in that perfect vacuum, tiny, invisible particles are constantly flickering in and out of existence. That's what virtual particles are. They are not particles like the ones you see in a lab, but fleeting disturbances that pop up and vanish almost instantly. They appear because of the strange rules of quantum mechanics, which tell us that certain properties, like energy and time, can't both be precisely known at the same moment. This uncertainty allows the vacuum to borrow tiny amounts of energy for a brief moment, creating pairs of virtual particles and antiparticles. These pairs form and then annihilate each other so quickly that they are practically impossible to detect directly. In the world of zero-point energy, which is the lowest possible energy a quantum system can have, these virtual particles play a big role. Even when everything seems perfectly still and cold, the vacuum isn't truly empty. Instead, it's buzzing with these tiny fluctuations of energy caused by virtual particles constantly appearing and disappearing. This background energy is what we call zero-point energy, and it exists everywhere. It's like a restless ocean of invisible activity, even at absolute zero temperature, where classical physics says all motion should stop. Scientists have observed some strange effects linked to virtual particles. One example is the Casimir effect, where two uncharged metal plates in a vacuum are pulled together. This happens because virtual particles create a pressure difference between the inside and outside of the plates. Another fascinating phenomenon is Hawking radiation, where black holes can emit particles due to virtual particle pairs forming near the event horizon. These effects show that virtual particles are more than just theoretical ideas. They have real, measurable influences on the universe. From a weird science point of view, virtual particles make the vacuum seem alive and restless. They challenge our simple idea of empty space as nothingness. Instead, they suggest that even in the emptiest regions of space, there's a constant dance of tiny energy fluctuations. Some scientists even speculate that if we could harness zero-point energy, we might tap into this invisible power source. While that idea remains speculative and faces many scientific hurdles, it sparks the imagination about what might be possible someday. In the end, virtual particles are like ghostly actors in the grand play of the universe. They appear and vanish in the blink of an eye, yet they influence everything from the tiniest atoms to the vast cosmos. Their existence hints at a universe filled with mysterious forces and energies that we are only beginning to understand. They reminded us that, even in the emptiest space, there is a hidden world of strange, energetic activity waiting to be explored.